Hello there. I'm so glad you're here with me tonight. Tonight, we're going to explore one of the most beautiful mysteries the universe has ever whispered to us. Does time actually exist? It's a question that feels both simple and impossibly deep, like asking whether the color blue is real or just something our minds paint onto the world. And, if you don't mind, I'd love to know, where in the world are you watching from? And what time is it where you are right now, whatever hour it might be? Morning, afternoon, or deep into the night? Isn't it curious that we're both here, scattered across the globe, sharing this moment about time itself? You might be settling in for sleep, or perhaps you're curious and wide awake. Either way, we're going to take this journey together, slowly and gently, through the strange landscape of time, or what we think time might be. So wherever you are, whatever time it is, let's begin this gentle exploration of the most invisible thing that shapes every moment of our lives: the feeling of time versus the fact of it. Have you ever noticed how a minute waiting for the microwave feels completely different from a minute laughing with a friend? The clock insists they're identical, 60 seconds each, perfectly measured, but your mind knows better. 1 minute crawls like honey from a spoon, the other vanishes faster than steam from your morning coffee. This is our first clue that time might not be quite what it seems. Your brain doesn't experience time the way a clock measures it. Instead, it's more like an artist painting each moment with different colors, stretching some into long, languid strokes and compressing others into tiny, bright dots. When you're bored, waiting in line at the post office, your brain becomes hyper-aware of the passing seconds. It's as if your mind turns into an over-enthusiastic drummer, tapping out each beat of boredom with painful precision. Tick, tick. Each second announces itself like an unwelcome guest who won't leave. But when you're absorbed in something beautiful, reading a captivating book, watching the sunset paint the sky, or deep in conversation with someone you love, time becomes a magician. It slips away unnoticed, leaving you surprised when you finally glance at the clock. How did 3 hours pass so quickly? You wonder, as if time had been playing a gentle trick on you. This isn't just a quirk of human experience, it's a fundamental clue about the nature of time itself. The fact that your brain can stretch and compress time suggests that time isn't the rigid, unchanging ruler we often imagine it to be. Instead, it's something more fluid, more personal, more alive. Consider this: when you're in danger, time often slows to a crawl. People who've been in car accidents often describe those crucial seconds stretching out like taffy, every detail crystallizing with impossible clarity. It's as if your brain, sensing the importance of the moment, switches to high-definition mode, recording every millisecond with the urgency of a war correspondent. Scientists have a name for this: subjective time. It's the time you feel, as opposed to objective time, the time that clocks measure. But here's the fascinating part. Which one is more real? The clock insists that 5 minutes is always 5 minutes. But your experience tells you that 5 minutes can feel like 5 seconds or 5 hours, depending on what you're doing and how you're feeling. This creates a beautiful paradox. We live in a world full of clocks, all ticking in perfect synchronization, all agreeing on what time it is. But we also live in our own private time zones, each of us experiencing the flow of moments differently. You might be early for everything, while your friend is perpetually late, not because you read clocks differently, but because you feel time differently. Think about your childhood summers. Do you remember how they seemed to stretch endlessly, each day a vast ocean of possibility? Time moved like honey back then, slow and golden and sweet. But now, as an adult, summers flash by like lightning, leaving you wondering where June went and how it's already September. This isn't just nostalgia playing tricks on you, it's actually a result of how your brain processes new experiences. When you're young, everything is new. The feel of grass under your feet, the taste of your first ice cream cone, the sound of rain on the roof. Your brain, encountering all these novel experiences, records them with extraordinary detail, creating rich, layered memories that feel expansive when you look back on them. But as you get older, many experiences become familiar. Your commute to work, your morning coffee routine, the shows you watch, they're comfortable and pleasant, but they're not new. Your brain, being efficient, doesn't bother recording every detail of familiar experiences. Instead, it creates simplified summaries, like a photographer taking fewer pictures of a scene they've photographed many times before. When you look back, those summarized memories feel shorter, compressed. It's as if your brain has edited out the repetitive parts, leaving only the highlights. This is why a year in childhood can feel like a decade in memory, while a year in adulthood can feel like it passed in the blink of an eye. But here's the beautiful part. You can still stretch time when you seek out new experiences, when you pay attention to the small details of your daily life, when you really notice the taste of your coffee or the way light falls through your window. Time begins to expand again, not because the clock changes, but because your brain starts recording in high definition once more. This suggests something profound about the nature of time. Maybe time isn't just something that happens to us. Maybe it's something we participate in creating moment by moment through our attention and our awareness. The clock may tick at a steady pace, but the time we actually live, the time we remember, the time we feel, is something we paint with our own consciousness. Why waiting feels longer than doing. There's a cruel joke the universe plays on us. The things we least want to do always seem to take the longest. Waiting in line, sitting in a dentist's chair, enduring a boring meeting. These moments crawl by like they're moving through molasses. But the activities we love, conversations with friends, walks in nature, losing ourselves in a good book, these zip by so quickly, we barely notice them passing. This isn't just your imagination being dramatic. Your brain literally processes empty time differently than filled time. When you're actively engaged in something, your brain is busy processing information, making connections, solving problems. It's like a jazz musician improvising, completely absorbed in the flow of creation, with no mental bandwidth left over to monitor the clock. But when you're waiting, your brain suddenly has nothing to do but pay attention to time itself. It's like having a hyperactive child, with nothing to play with. All that restless energy turns toward the one thing available, the slow, steady march of seconds. Your brain becomes a time-watching specialist, cataloging each moment with the dedication of a monk counting prayer beads. Imagine your brain as a spotlight. When you're engaged in an activity, that spotlight is focused outward, on the book you're reading, the person you're talking to, the problem you're solving. Time exists in your peripheral vision, noticed but not scrutinized. But when you're waiting, that spotlight swings around and focuses directly on time itself, illuminating every slow second with uncomfortable clarity. This is why a watched pot never boils. When you stand there staring at the water, your brain has nothing to do but monitor the heating process. Every moment becomes magnified, stretched, examined. The water seems to take forever to reach that first bubble, that first whisper of steam. But if you wander away, distracted by other tasks, you'll often return to find the water boiling merrily, as if it had been waiting for you to stop watching. Psychologists call this the temporal illusion. Your brain's perception of time is deeply influenced by what you're paying attention to. When your attention is focused on time itself, time seems to slow down. When your attention is focused elsewhere, time seems to speed up. It's as if time is a shy creature that only moves freely when you're not looking directly at it. This creates an interesting paradox for anyone trying to make time pass more quickly. The more you want time to move fast, the more you pay attention to it, and the slower it seems to move. It's like trying to fall asleep. The harder you try, the more elusive sleep becomes. The secret to making time pass quickly is to forget about time altogether, to become so absorbed in something else that time disappears from your awareness. But waiting isn't just about having nothing to do, it's also about anticipation. And anticipation has its own strange relationship with time. When you're waiting for something you're looking forward to, a vacation, a date, a delicious meal, your brain becomes like a child on Christmas morning, practically vibrating with excitement. This heightened state of anticipation makes you hyper-aware of every passing moment, as if your brain is shouting, "Is it time yet? How about now? Now." On the other hand, when you're waiting for something you're dreading, a doctor's appointment, a difficult conversation, a deadline, your brain enters a different kind of time distortion. It's as if your mind is trying to slow down time, to postpone the inevitable for as long as possible. Each moment becomes heavy with dread, weighted down by the knowledge of what's coming. This is why the night before a big presentation or exam can feel endless. Your brain, aware of the approaching challenge, seems to stretch each hour like taffy, giving you more time to worry, more time to imagine all the things that could go wrong. It's not being helpful, it's just responding to the emotional weight of anticipation. But here's something beautiful. The way we experience waiting can actually teach us something profound about the nature of time. When you're waiting, you're experiencing pure time. Time stripped of content. Time without distraction. It's like looking at time naked, seeing it for what it really is rather than what it appears to be when dressed up in activities and events. And what you discover is that time without content feels completely different from time with content. Empty time is thick, viscous, almost tangible. It has weight and texture. It presses against your consciousness like a heavy blanket. This suggests that time might not be the invisible, ethereal thing we usually imagine it to be. Maybe time has its own presence, its own substance, something we only notice when we're forced to sit alone with it. Think about meditation, which is essentially the practice of sitting with empty time. Beginning meditators often struggle with this, finding that 10 minutes of sitting quietly feels like an eternity. But experienced meditators report something different. They describe entering a state where time seems to dissolve entirely, where minutes or hours can pass without any sense of duration at all. This suggests that our relationship with time is learnable, changeable. We can train ourselves to experience time differently, to find peace in waiting, to discover richness in what initially feels like emptiness. It's as if time is a musical instrument, and we can learn to play it with greater skill and subtlety. Some cultures have understood this intuitively. In many Mediterranean cultures, the concept of island time reflects a different relationship with waiting and timing. Rather than seeing waiting as lost time, it's seen as gift time. Moments to chat with a neighbor, to watch the world go by, to simply exist without urgency. Time becomes less about efficiency and more about presence. This different relationship with time can transform waiting from torture into opportunity. Instead of fighting against the slow passage of moments, you can learn to inhabit them fully, to find texture and interest in the simple act of existing in time. Waiting becomes less about enduring and more about experiencing time and memory. The hidden architects of experience. Your memories are liars, beautiful, creative, necessary liars. They don't record time the way a video camera does, capturing each second with mechanical precision. Instead, they're more like poets, taking liberties with the truth to create something more meaningful than mere facts. And in their creative reconstruction of your past, they reveal something profound about the nature of time itself. Think about your most vivid memories. Chances are, they're not complete recordings of entire days or weeks. Instead, they're moments, bright islands of experience floating in a sea of forgotten time. Your first kiss, the moment you heard devastating news, the smell of your grandmother's kitchen, the feeling of accomplishment after achieving something difficult. These memories arrive complete and immediate, as if they happened yesterday, even if they're decades old. But between these vivid moments, vast stretches of time have vanished completely. What did you have for lunch 3 Tuesdays ago? What did you think about during your commute last Thursday? What was the weather like on an ordinary day in March 2 years ago? These experiences have been edited out of your personal archive, not because they weren't real, but because your brain has decided they weren't worth preserving in detail. This selective editing reveals something crucial about how you experience time. Your brain doesn't experience time as a continuous flow, it experiences it as a series of moments, some bright and memorable, others dim and forgettable. It's like watching a movie that's been edited to show only the most important scenes, with the boring parts cut out entirely. This is why your childhood feels so long when you remember it. Your brain was encoding everything as a first time, first day of school, first bicycle ride, first taste of chocolate ice cream. Each experience was novel and worth remembering in detail. But as you get older, many experiences become repetitive. Your brain, being efficient, starts creating mental shortcuts, summarizing routine experiences rather than recording them fully. It's like the difference between visiting a new city and living in your hometown. In the new city, you notice everything: the architecture, the sounds, the smells, the way people walk and talk. Every block is an adventure worth remembering. But in your hometown, you can drive familiar routes without really seeing them. Your brain on autopilot, creating only the most basic memories necessary for navigation. This editing process explains why time seems to accelerate as you age. It's not that time is actually moving faster, It's that your brain is creating fewer detailed memories to look back on. When you remember a year from your childhood, you're remembering dozens of vivid, detailed experiences. When you remember a recent year, you might only be remembering a handful of standout moments, making the year feel shorter in retrospect. But here's the fascinating part. Your brain doesn't just edit out uninteresting moments, it also edits the interesting ones, and it does so in very specific ways. Psychologists have discovered that you remember the beginning and end of experiences much more clearly than the middle. They call this the serial position effect, and it applies to everything from lists of words to entire life experiences. Think about a vacation you took. You probably remember the excitement of departure, the novelty of the first few days, and the bittersweet feeling of the last evening. But the middle days, even if they were pleasant, might blur together in your memory. Your brain has compressed a week of experiences into a handful of vivid bookends, creating a memory that feels complete even though most of the actual time has been edited out. This editing process creates a strange paradox. The memories that feel most real to you, most true to your experience, are actually the most constructed, the most edited. Your brain has taken the raw footage of your life and created a highlight reel, a greatest hits album of your experiences, and this edited version feels more real than the original because it's been crafted to feel meaningful and coherent. But memory doesn't just edit your past, it also shapes your future. When you imagine future events, your brain uses the same neural networks that create memories. It's essentially creating memories of things that haven't happened yet, drawing on past experiences to construct plausible futures. This means your sense of future time is just as constructed, just as edited, as your sense of past time. This has profound implications for how you experience time. If your memories are constructed rather than recorded, then your sense of personal time, the narrative of your life, is also constructed. You're not just living through time, you're actively creating your experience of time through the stories you tell yourself about your past and future. This suggests that time might not be the objective, external thing we usually imagine it to be. Instead, it might be something more collaborative, something that emerges from the interaction between events in the world and the meaning-making machinery of your mind. Time doesn't just happen to you. You participate in creating it through your attention, your memory, and your imagination. Consider how this works in practice. When you're deeply engaged in an activity, your brain is focused on the present moment, creating rich, detailed memories. Time feels full and meaningful. When you're distracted or disengaged, your brain creates sparse, shallow memories. Time feels empty and forgettable. The quality of your attention literally shapes the texture of your time. This explains why mindfulness practices can transform your experience of time. When you pay careful attention to the present moment, you're giving your brain more material to work with when it creates memories. You're essentially increasing the resolution of your time, making each moment more vivid and meaningful. The result is that time feels richer, more substantial, more real. It also explains why new experiences can make time feel longer. When you travel to a new place, learn a new skill, or meet new people, your brain has to work harder to process and store all that novel information. This creates denser, more complex memories, which make time feel fuller and longer when you look back on it. The elastic now. What is now? It seems like the simplest question in the world, but the more you think about it, the more mysterious it becomes. Are you experiencing now as you read these words? But by the time you finish this sentence, that now has become then. The present moment seems to slip away the instant you try to grasp it, like water running through your fingers. This slippery nature of the present moment has puzzled philosophers and scientists for centuries. If the past is gone and the future hasn't arrived yet, then now should be the only thing that's real. But when you try to pin down exactly what now is, it becomes strangely elusive. It's like trying to find the exact spot where day becomes night. You know it happens, but you can't quite catch it in the act. Your brain, it turns out, doesn't experience now as a single precise moment. Instead, it creates what scientists call the spacious present, a thick slice of time that feels like now, but actually includes a bit of the immediate past and a hint of the immediate future. It's as if your brain takes a small chunk of time, maybe 2 or 3 seconds long, and presents it to your consciousness as a single, unified moment. This is why you can understand a sentence as you hear it. Even though the words arrive one at a time, your brain holds the beginning of the sentence in a kind of temporal buffer, while it waits for the rest, then presents the entire sentence to your consciousness as a single, meaningful unit. The now of understanding isn't a knife-edge moment, but a gentle gathering of sequential sounds into coherent meaning. You can feel this elastic quality of the present moment in music. When you listen to a melody, you're not just hearing individual notes in isolation. Instead, your brain is weaving those notes together into a flowing pattern that exists in your extended present. You hear the relationship between the notes, the way they move from one to another, the way they create tension and resolution. The melody exists not in any single moment, but in the flowing connection between moments. This extended present is constantly shifting, like a spotlight moving across the landscape of time. What was future becomes present, what was present becomes past. But the spotlight itself, your now, remains constant. It's a moving window through which you observe the flow of time, but the window itself seems to exist outside of time. But here's where it gets really interesting. The size of your now isn't fixed. It can expand and contract depending on what you're doing and how you're feeling. When you're completely absorbed in an activity, what psychologists call flow, your sense of now can expand dramatically. Musicians often describe this. When they're playing, especially with other musicians, the present moment becomes elastic, stretching to accommodate complex improvisations and subtle interactions. Time doesn't disappear exactly, but it becomes more fluid, more spacious. Athletes experience this too. A baseball player at bat doesn't just see the ball at a single moment, they see its trajectory, its spin, its path through space. Their now expands to encompass the entire flight of the ball, allowing them to make split-second decisions that would be impossible if they were stuck at a knife-edge present. At the other extreme, when you're anxious or in pain, your now can contract to an almost unbearable thinness. Each moment becomes sharp and immediate, without the cushioning of the extended present. Time feels jagged, fragmented, as if you're being forced to experience each second individually, rather than as part of a flowing stream. This elasticity of the present moment suggests something profound about the nature of time. If now can stretch and contract, if it can be thick or thin, spacious or cramped, then maybe time isn't the rigid framework we usually imagine it to be. Maybe it's more like a living thing, breathing and shifting, and adapting to our needs and circumstances. Consider how this works in conversation. When you're talking with someone, your now expands to include not just your own words but their words, their expressions, their responses. You're not just speaking in your own isolated moment, you're participating in a shared present that encompasses both of you. The conversation exists in a kind of mutual now, a temporal space that neither of you owns but both of you inhabit. This shared present is part of what makes human connection so meaningful. When you're really present with someone, when you're fully engaged in the moment together, you're not just occupying the same physical space, you're sharing the same temporal space. Your nows overlap and interweave, creating a richer, more complex present than either of you could create alone. Love, in many ways, is this expansion of the present moment. When you're with someone you love, time often feels different, more spacious, more meaningful, more real. It's as if your individual nows combine to create a larger, more generous present. This is why lovers often describe time as stopping when they're together, or why hours can pass unnoticed in the company of someone you care about. But the elastic nature of now also reveals something about the fundamental structure of consciousness itself. Your awareness seems to exist in this expanded present, this thick slice of time that includes memory of the immediate past, and anticipation of the immediate future. You're never purely in the present moment, you're always carrying traces of what just happened and hints of what's about to happen. This creates a beautiful paradox. The present moment, which should be the most real and immediate thing in your experience, is actually a construction, a synthesis of past and future into something that feels like now. Your brain is constantly creating the present moment by weaving together memory, sensation, and an anticipation into a seamless experience of now. This suggests that time might not be something that just happens to you, but something you actively participate in creating. Your consciousness doesn't just observe time passing, it creates the experience of temporal flow by synthesizing different moments into a coherent present. You're not just living in time, you're creating time moment by moment through the very act of being aware. The arrow of time. Here's something odd about your relationship with time. You can remember eating breakfast this morning, but you can't remember eating breakfast tomorrow morning. You know what happened yesterday, but you have no idea what will happen tomorrow. This might seem so obvious that it's not worth mentioning, but it's actually one of the deepest mysteries in the universe. Why does time have a direction? Why can you remember the past, but not the future? Why does cause come before effect, never the other way around? These questions might sound simple, but they've puzzled the greatest minds in physics for over a century. The equations that describe the fundamental forces of nature, gravity, electromagnetism, the strong and weak nuclear forces, work just as well running backward as forward. At the deepest level, the laws of physics don't seem to care which direction time flows. Imagine watching a movie of a single atom bouncing around in space. If someone played that movie backward, you wouldn't be able to tell the difference. The atom would still follow the same laws of physics, just in reverse. But if someone showed you a movie of an egg falling off a table and splattering on the floor, you'd immediately know if they played it backward. Eggs don't spontaneously reassemble themselves and leap back onto tables. This difference reveals something profound about the nature of time. At the microscopic level, time seems to be reversible. Individual particles and atoms don't have a preferred direction in time. But at the macroscopic level, the level of eggs and people and planets, time clearly has an arrow. It points from past to future, from cause to effect, from order to disorder. The key to understanding this arrow of time lies in a concept called entropy. Entropy is often described as a measure of disorder, but it's more subtle than that. It's really a measure of how many different ways things can be arranged. A clean room has low entropy because there are relatively few ways to arrange things neatly. A messy room has high entropy because there are countless ways to scatter things around. The second law of thermodynamics states that entropy always increases over time. Things tend to become more disordered, more scattered, more mixed up. This isn't a law about how things must behave. It's a law about probability. There are simply more ways for things to be disordered than ordered, so disorder is more likely. Think about stirring cream into coffee. When you first pour the cream in, it forms distinct swirls and patterns. But as you stir, the cream and coffee mix together until they form a uniform light brown liquid. You'll never see the reverse happen. You'll never stir a cup of light brown coffee and have it separate into distinct regions of black coffee and white cream. Not because it's impossible, but because it's astronomically unlikely. This tendency toward increasing entropy is what gives time its arrow. The future is the direction in which entropy increases. It's the direction in which things become more mixed up, more spread out, more disordered. The past is the direction from which things were more ordered, more organized, more concentrated. But here's the beautiful part. This arrow of time isn't just a feature of the physical world. It's also intimately connected to memory, consciousness, and information. Your ability to remember the past, but not the future, is actually a consequence of the same thermodynamic processes that make cream mix into coffee. Memory requires creating records, patterns of information that persist over time. When you remember something, you're accessing a record that was created in the past. But creating these records requires energy, and using energy always increases entropy. Your brain, in the process of forming memories, is participating in the same thermodynamic dance that makes eggs fall and cream mix. This is why memory is inherently linked to the arrow of time. You can only remember things that happened in the direction of increasing entropy. You can't remember the future because the future is the direction in which entropy increases. And you can't create records of events that haven't happened yet. This connection between memory and entropy reveals something profound about consciousness and time. Your awareness of time's passage, your sense of moving from past to future, is actually a consequence of the thermodynamic processes happening in your brain. You experience time's arrow because you are time's arrow. You're part of the same universal process that makes things become more disordered over time. But this raises a fascinating question. If the arrow of time is just a consequence of increasing entropy, what happens when entropy stops increasing? In the far future, when the universe has reached maximum entropy, when all the stars have burned out and all the black holes have evaporated, will time stop having a direction? Will the arrow of time disappear? Some physicists speculate that in such a universe time might indeed become reversible. Without the thermodynamic gradient that drives entropy increase, there would be no preferred direction in time. The universe would exist in a kind of eternal present, with no distinction between past and tis. It's a strange and haunting vision, a universe where time has lost its way, where cause and effect have no meaning, where memory and forgetting become impossible. But perhaps this far future holds a different kind of beauty. Without the arrow of time, without the relentless march from order to disorder, the universe might find new forms of organization, new patterns of existence that don't depend on the linear progression from past to future. Time might not end, but transform, becoming something rich and strange and wonderful that we can barely imagine. For now, though, we live in an era when time has a clear direction. We live in the flowing stream of entropy, increase, carried along by the universal tendency toward greater disorder. And paradoxically, this apparent trend toward disorder is what makes order possible. It's what allows patterns to form, information to be processed, memories to be created, and consciousness to exist. The arrow of time isn't just a feature of the universe. It's the feature that makes everything else possible. It's what allows stories to have beginnings, middles, and ends. It's what allows causes to create effects, seeds to become trees, and thoughts to become memories. Without the arrow of time, the universe would be a timeless maze of possibility, beautiful perhaps, but empty of the narrative structure that gives meaning to existence. Entropy, the universe's gentle drift toward disorder. There's something both melancholy and beautiful about entropy, the universe's slow, inevitable drift toward disorder. It's the reason your coffee always cools down and never heats up on its own. It's why your bedroom becomes messy faster than it becomes clean. Why flowers eventually wilt. Why ice cubes melt, but never spontaneously freeze. Entropy is the universe's way of saying that all things tend toward a gentler, more scattered state. But entropy isn't the villain it's often made out to be. It's not destruction or decay in the harsh sense. It's more like a universal exhale, a gradual releasing of tension, a slow settling into comfort. Think of it as the universe's way of relaxing, of letting go of the tight, concentrated energy that once held everything in precise arrangements. When you drop a sugar cube into a cup of tea, you're witnessing entropy in action. The sugar doesn't stay in a neat little cube. It dissolves, spreads, mingles with the liquid until it's distributed evenly throughout. The sweetness that was once concentrated in a small space is now gently scattered through the entire cup. The tea hasn't become chaotic or destroyed. It's simply become more evenly mixed, more balanced, more at ease with itself. This is entropy's gentle magic. It takes concentrated energy and spreads it out, takes hot spots and cool spots, and brings them toward a common temperature, takes order and disorder and finds a middle ground where everything is more evenly distributed. It's the universe's way of sharing, of making sure that no single place hoards all the energy, while others go without. Your body is constantly dancing with entropy. Every breath you take, every heartbeat, every thought in your mind is part of an intricate balance between order and disorder. Your cells work tirelessly to maintain their organization, to keep proteins folded properly, to maintain the delicate chemical gradients that allow life to exist. But they can only do this by using energy, and every use of energy increases entropy somewhere else. When you eat food, you're consuming low entropy energy. Complex molecules with concentrated chemical potential. Your body breaks these down, extracts the energy, and uses it to maintain your biological organization. But in the process, it releases high entropy energy, heat, waste products, simple molecules that can't be used for biological work. You maintain your personal order by contributing to the universe's overall disorder. This might sound depressing, but it's actually profoundly beautiful. Every moment of your life, every thought you think, every love you feel, every creative act you perform exists in tension with entropy. Life is the universe's way of creating temporary islands of order in the sea of increasing disorder. You are an entropy-defying miracle, a complex pattern that maintains itself by dancing with the universal tendency toward chaos. But entropy isn't just about physics, it's about information, meaning and memory. When you forget something, entropy is at work. The neural patterns that encoded a memory gradually degrade. The precise arrangements of proteins and neurotransmitters that held information slowly drift toward more random configurations. Forgetting is entropy applied to memory. the universe's way of ensuring that information doesn't accumulate indefinitely. This entropic nature of memory creates a bittersweet beauty. The fact that memories fade means that each moment of remembering is precious, temporary, irreplaceable. Your memories of childhood summers, of first loves, of conversations with grandparents who are gone, these exist in constant tension with entropy, maintained by the energy your brain expends in remembering, always at risk of dissolving back into the general disorder of forgotten things. But entropy also makes new memories possible. If your brain couldn't forget, couldn't allow old patterns to degrade and new ones to form, you'd be trapped in a crystalline prison of perfect recall. Entropy's gentle erosion of memory is what allows you to learn new things, to form new associations, to let old hurts heal and new loves bloom. Forgetting is not just loss, it's also liberation. The relationship between entropy and time creates one of the most poetic aspects of existence. Entropy always increases, which means the future is always more disordered than the past. But this doesn't mean the future is worse or less meaningful. It means the future is more mixed up, more blended, more integrated. The sharp edges of the past get softened. The stark contrasts get blended into more subtle gradients. Think about how this works in your own life. The intense emotions of youth, the sharp pangs of first heartbreak, the burning ambition of early career, the clear-cut certainties of young adulthood. These tend to soften over time, not because they become less real or less important, but because they become more integrated into the complex tapestry of your personality. Entropy doesn't destroy these experiences. It weaves them into the more nuanced, more balanced person you become. This entropic evolution of personality is part of what makes aging beautiful rather than just sad. Yes, you lose some of the sharp intensity of youth, but you gain something else, a more evenly distributed wisdom, a more balanced perspective, a personality that has been gently mixed and blended by time into something richer and more complex than what you started with. Entropy also explains why the universe is so remarkably creative. The second law of thermodynamics says that entropy always increases, but it doesn't say how it increases. There are countless ways for disorder to grow, countless paths from order to chaos. This means that entropy doesn't just drive the universe toward a boring, uniform state. It drives it toward an incredible diversity of possible states. Every snowflake that forms is entropy at work, taking the ordered energy of water vapor and releasing it in a beautifully disordered crystal pattern. Every galaxy that swirls is entropy in action, taking the concentrated energy of gravitational collapse and spreading it out in spiral arms that span hundreds of thousands of light years. Every song that brings tears to your eyes is entropy made manifest, taking the ordered energy of human emotion and releasing it in patterns of sound that touch something deep in your soul. The illusion of flow. Does time actually flow, or are we the ones moving through it? This question might sound like philosophical hair-splitting, but it touches on something profound about the nature of time itself. When you think about time, you probably imagine it flowing like a river, carrying you from past to future. But what if time is more like a landscape, static and unchanging, and you're the one moving through it like a traveler on a journey? This distinction isn't just academic. It completely changes how we understand the nature of existence itself. If time flows, then the present moment is special, uniquely real, while the past and future are somehow less real. But if time is static, and we move through it, then every moment that ever was or ever will be exists simultaneously, spread out across the landscape of time, like cities on a map. Einstein believed in the second view. He famously said that the distinction between past, present, and future is only a stubbornly persistent illusion. According to his theory of relativity, all moments in time exist equally. The past hasn't disappeared and the future hasn't arrived yet. They're all there, laid out in what physicists call the block universe, a four-dimensional structure where time is just another dimension like length, width, and height. This idea feels strange because it's so different from our everyday experience. When you remember your 5th birthday, it doesn't feel like you're accessing something that still exists somewhere in the fabric of space-time. It feels like you're recalling something that's gone, something that exists only in the patterns of your memory. But according to the block universe theory, that birthday party is still happening, still real, still present, just in a different location in the dimension of time. Imagine time as a vast library. In this library, Every moment your life is a book on the shelf. Your birth is there, your first day of school, your wedding day, the moment you're reading these words, and your eventual death. All these books exist simultaneously in the library of time. Your consciousness is like a reader moving through the library, opening one book after another, experiencing each moment as now as you encounter it. But here's the strange part. In this library, you're not just the reader, you're also a character in every book. There's a version of you at 5 years old, still blowing out birthday candles in the section of the library labeled your past. There's a version of you at 90, still experiencing whatever that moment holds in the section labeled your future. All these versions of you exist simultaneously, each one experiencing their moment as the present, each one convinced that theirs is the only real now. This creates a beautiful paradox. If all moments exist equally, then your childhood self is still experiencing the wonder of those early years, still feeling the excitement of discovery, still believing that summer will last forever. Your future self is still experiencing whatever joys and sorrows await, still feeling the richness of existence, still living in their own now. In a sense, every version of you that ever was or ever will be is still alive, still present, still real. But if this is true, then what creates the illusion of flow? Why does time feel like it's moving if all moments exist equally? The answer might lie in the nature of consciousness itself. Your awareness seems to move through the block universe like a spotlight, illuminating one moment after another, creating the subjective experience of temporal flow. Think about watching a movie. The entire film exists on the reel or in the digital file. Beginning, middle, and end are all there simultaneously. But when you watch the movie, you experience it as flowing, as moving from scene to scene. The flow isn't in the movie itself, it's in your experience of the movie. Perhaps the flow of time is similar. Not a feature of time itself, but a feature of how consciousness experiences time. This suggests that the flowing quality of time might be something consciousness adds to the universe, not something that exists independently in the fabric of space-time. Your brain, processing information sequentially, creates the subjective experience of temporal flow. It's as if consciousness is a movie projector, taking the static frames of the block universe and projecting them in sequence to create the illusion of movement. But this raises profound questions about the nature of free will and choice. If all moments exist equally, if your future decisions are already out there in the block universe, then are you really making choices? Or are you just discovering choices that already exist? When you decide to have coffee instead of tea, are you creating the future, or are you simply moving to the part of the block universe where that choice exists? Some philosophers argue that free will is perfectly compatible with the block universe. They point out that your choices are still real, still meaningful, still yours. They're just eternal rather than temporal. The decision to be kind to a stranger, to pursue a dream, to love someone deeply, these choices exist forever in the structure of space-time, unchanging and eternal. In a sense, this makes them more real, not less. Others find this view deeply troubling. If everything is already determined, if all moments exist equally, then what's the point of striving, of hoping, of trying to make the world better? But perhaps this misses the point. Your striving, your hoping, your efforts to improve the world, these are all part of the eternal structure of the block universe. They're not rendered meaningless by their eternality, they're rendered timeless. Consider love in this context. If the block universe is real, then every moment of love you've ever experienced still exists, still radiates its warmth somewhere in the dimension of time. Your first crush, your deepest relationships, the love you feel for family and friends, all of these exist eternally, immune to the ravages of time. Love doesn't fade in the block universe. It becomes part of the permanent structure of reality. This eternal nature of experience creates a strange kind of comfort. Every moment of joy, every instance of beauty, every connection with another person becomes immortal. The laughter of children, the warmth of sunlight, the satisfaction of meaningful work, these don't pass away in the block universe. They become part of the eternal fabric of existence, always there, always real, always present in their own slice of time. But the block universe also preserves pain, loss, and suffering. Every moment of grief, every instance of heartbreak, Every experience of fear or loneliness also exists eternally. This might seem like a harsh aspect of this view of time, but it also suggests that suffering, like joy, is part of the complete tapestry of existence. The moments of pain give meaning to the moments of pleasure. The experiences of loss give weight to the experiences of love. Whether time flows or we flow through time remains one of the deepest mysteries in physics and philosophy, but perhaps the mystery itself is part of the beauty. The fact that we can even ask these questions, that we can wonder about the nature of our own existence in time, suggests something profound about consciousness and its relationship to the cosmos. We are not just passive observers of time, we are active participants in the mystery of temporal existence. Einstein's time? Bent, slow, and personal. Albert Einstein gave us perhaps the most beautiful and disturbing gift in the history of science. He showed us that time is not what we thought it was. Time, he revealed, is not a cosmic metronome ticking away uniformly throughout the universe. Instead, it's personal, flexible, and surprisingly fragile. It can slow down, speed up, and even bend under the right circumstances. This discovery began with a simple observation. Light always travels at the same speed, no matter how fast you're moving when you measure it. This might not sound revolutionary, but it contradicted everything we thought we knew about motion and time. If you're driving toward a streetlight, the light from that lamp should appear to reach you faster than if you were driving away from it. But Einstein realized that this isn't what happened. Light always approaches you at exactly the same speed, regardless of your motion. This led to a startling conclusion. If the speed of light is constant, then something else must be variable, and that something else is time itself. Time must slow down, or speed up, to keep the speed of light constant. This was the birth of special relativity, and it changed everything. Imagine you're on a train moving very fast, close to the speed of light. To you, everything on the train seems normal. Your watch ticks at its usual pace. Your coffee cools at its normal rate. Your thoughts flow at their regular speed. But to someone standing on the platform watching your train pass by, something extraordinary is happening. Your time is running slow. Your watch appears to tick more slowly. Your coffee seems to cool more gradually. Your movements appear sluggish and dreamlike. This isn't just an optical illusion or a trick of perspective. Time itself is actually running more slowly for you relative to the person on the platform. If you could somehow travel at 99.9% the speed of light for what feels like a year to you, you would return to find that decades had passed on Earth. Your friends would have aged, your children would have grown up, the world would have changed in ways you could never have imagined. This time dilation effect has been measured countless times in experiments. Atomic clocks flown on airplanes run slightly slow compared to identical clocks left on the ground. Particles called muons, created in the upper atmosphere, live longer than they should because they're moving so fast that time slows down for them. GPS satellites have to account for time dilation effects, or they would accumulate errors that would make navigation impossible. But Einstein's insights didn't stop with motion. He realized that gravity too affects the flow of time. The stronger the gravitational field, the slower time runs. This means that time moves slightly more slowly on the ground floor of a building than on the top floor. The effect is tiny, we're talking about differences measured in billionths of a second, but it's real and measurable. Near massive objects like stars or black holes, this gravitational time dilation becomes dramatic. If you could somehow survive standing on the surface of a neutron star, where gravity is billions of times stronger than on Earth, your time would run noticeably slow compared to someone far from the star. What feels like minutes to you might correspond to hours for a distant observer. This personal nature of time creates beautiful paradoxes. Imagine identical twins, one of whom becomes an astronaut and travels to a distant star at high speed, while the other stays on Earth. When the traveling twin returns, they will have aged less than their Earth-bound sibling. The twin who traveled will be younger, having experienced less time during their journey. They will have literally traveled into their sibling's future. But here's the most beautiful part. Neither twin is wrong about their experience of time. The traveling twin really did experience less time. Their clocks, their biology, their memories, everything confirms that less time passed for them. Meanwhile, the Earth-bound twin really did experience more time. Both experiences are equally valid, equally real. Time is not universal, it's personal. This personalization of time extends to every aspect of our existence. The time you experience is not the same as the time experienced by someone moving at a different speed or in a different gravitational field. In a very real sense, you carry your own time with you wherever you go. Your time is as unique to you as your fingerprints or your DNA. This creates a profound loneliness and a profound connection. The loneliness comes from the realization that you can never truly share time with another person. Your temporal experience is yours alone, running at its own pace, colored by your own motion and your own position in the gravitational field of the universe. No one else can step into your time stream and experience time exactly as you do. But the connection comes from the realization that everyone else is also carrying their own personal time, their own unique temporal experience. When you meet someone, you're not just sharing space. You're creating a temporary intersection of time streams, a moment where your personal time and their personal time briefly synchronize. Every conversation, every shared laugh, every moment of love is a miracle of temporal coordination. Einstein's revelation about time also suggests something profound about the nature of reality itself. If time is personal and flexible, then the universe is not the clockwork mechanism we once thought it was. Instead, it's something more like a symphony, where each part plays its own temporal melody, sometimes in harmony, sometimes in counterpoint, but always as part of a larger, more complex composition. This musical metaphor isn't just poetic, it's actually quite accurate. The mathematics of relativity are remarkably similar to the mathematics of music. Both deal with relationships between different frequencies, both involve harmonics and resonances. Both create patterns that can be beautiful or discordant depending on how they're arranged. Perhaps this is why Einstein was such a passionate amateur violinist. He understood that the universe itself is a kind of music, played out in the symphony of space-time. Every massive object bends the fabric of the universe, creating ripples and harmonics that propagate at the speed of light. Every motion, every acceleration, every gravitational interaction adds its own voice to this cosmic composition, and you are part of this music. Your personal time stream is your own unique melody line in the symphony of existence. Sometimes your melody harmonizes with others, creating moments of connection and understanding. Sometimes it plays in counterpoint, creating tensions and resolutions that give meaning to the overall composition. But always, it's your own song, your own contribution to the music of the cosmos. The clock that ages slower in space. There's a clock orbiting high above your head right now that's aging more slowly than you are. Not metaphorically, but literally. Time itself is running slower for that clock than it is for you, sitting here on Earth's surface. This isn't science fiction. It's a necessary feature of the GPS system that helps you navigate to the grocery store. The global positioning system consists of a constellation of satellites orbiting Earth at an altitude of about 20,000 kilometers. Each satellite carries extremely precise atomic clocks that tick billions of times per second. These clocks need to be synchronized to within a few nanoseconds for the system to work. Any significant timing error would make your GPS useless, potentially off by miles rather than meters. But here's the problem. According to Einstein's theory of relativity, those clocks should run at a different rate than clocks on Earth's surface. The satellites are moving fast relative to Earth, which should make their clocks run slow, but they're also farther from Earth's center, where gravity is weaker, which should make their clocks run fast. The net effect is that the satellite clocks gain about 38 microseconds per day, compared to Earth-based clocks. 38 microseconds might not sound like much, but it's enough to make GPS completely useless. Light travels about 300 meters in a microsecond, so a timing error of 38 microseconds would translate to a position error of more than 10 kilometers. Without correcting for these relativistic effects, your GPS would think you were in the next town over. This everyday example of time dilation reveals something profound about the nature of time. It's not just a theoretical concept confined to physics textbooks. It's a real measurable phenomenon that affects the technology we use every day. The fact that your smartphone can pinpoint your location to within a few meters is actually proof that Einstein was right about the nature of time. But the GPS satellites are just the beginning. Astronauts on the International Space Station are also aging more slowly than people on Earth's surface. The effect is tiny, only about a few microseconds per day, but it's real. If you could somehow live on the ISS for your entire life, you would age perhaps a few milliseconds less than your Earthbound twin. You would literally travel into their future, albeit by the tiniest amount. This time dilation effect becomes more dramatic as you move farther from Earth or travel at higher speeds. If you could somehow travel to the moon and back at a significant fraction of the speed of light, you would return to find that more time had passed on Earth than you experienced during your journey. The faster you travel, the more pronounced this effect becomes. At extreme speeds, approaching the speed of light, dilation becomes dramatic. If you could travel at 99.9% the speed of light to a star 100 light-years away and back, the journey would take you about 200 years, as measured by Earth-based observers. But due to time dilation, you would experience only about 14 years of subjective time. You would return to find that 2 centuries had passed on Earth, that everyone you knew was long dead, that the world had changed in ways you could never have imagined. This creates a beautiful and melancholy possibility: interstellar travel through time dilation. While we may never be able to travel faster than light, we can travel through time by moving at high speeds. The journey to the stars becomes a journey into the future, a one-way ticket to tomorrow. The explorers who make such journeys would be temporal refugees, forever cut off from their own time, forever living in the future of their birth era. But time dilation doesn't just affect clocks and astronauts. It affects everything. Every process, every chemical reaction, every biological function runs slower in a fast-moving or high-gravitational environment. If you could somehow survive in a strong gravitational field, not just your clocks, but your entire biology would run slow. Your heartbeat would be slower, your thoughts would be slower, your aging would be slower. You would literally live longer, not by surviving more years, but by having those years contain more time. This suggests something profound about the relationship between time and existence. We usually think of time as the stage on which life plays out, but relativity reveals that time is more like a participant in the drama. It's not just the backdrop against which events occur, it's an active player that can change the very nature of those events. Consider what this means for the experience of consciousness. If time can slow down or speed up, then consciousness, which seems to exist in time, must be affected as well. Your thoughts, your memories, your sense of self, all of these exist in your personal time stream. When that time stream slows down or speeds up, so does your inner experience. This creates a strange kind of solitude. Every conscious being exists in their own personal bubble of time, experiencing the flow of moments at their own unique rate. When you look up at the stars, you're not just seeing distant suns, you're seeing distant times, places where time itself might be running at a different pace than it is for you. But this solitude is also a kind of freedom. Your personal time is truly yours, shaped by your motion through space and your position in the gravitational fields of the universe. In a very real sense, you are the author of your own temporal experience. Every step you take, every elevation you climb, every speed you travel, all of these subtly influence the rate at which you experience time. This personalization of time also suggests something beautiful about relationships and connection. When two people are together, they're not just sharing space, they're synchronizing their personal time streams, creating a shared temporal experience. Love, in this context, becomes a kind of temporal harmony, a synchronization of different time experiences into a shared rhythm. The fact that time can slow down or speed up also opens up profound questions about the nature of eternity. If time is variable, then what does it mean for something to be eternal? Does eternity mean lasting forever in time, or does it mean existing outside of time altogether? Perhaps the deepest truths about existence are not those that last for all time, but those that exist in all times, principles and patterns that remain constant regardless of how fast or slow time might be running. Black holes and the vanishing of hours. At the edge of a black hole, time begins to behave in ways that seem almost magical. As you approach the event horizon, that invisible boundary beyond which not even light can escape, time starts to slow down dramatically. From the perspective of someone watching you from a safe distance, you would appear to slow down, your movements becoming more and more sluggish, until you seem to freeze entirely at the horizon, your image slowly fading to red, and then to darkness. But from your perspective, something entirely different would be happening. You wouldn't feel time slowing down at all. Your watch would tick normally, your thoughts would flow at their usual pace, Your heart would beat at its regular rhythm. You would cross the event horizon and continue falling toward the center of the black hole, experiencing time exactly as you always have. The slowing of time would be invisible to you, detectable only by comparing your experience to that of distant observers. This creates one of the most profound paradoxes in all of physics. Two equally valid perspectives on the same event, one in which time stops, another in which it continues normally. Both are correct, both are real, both describe what actually happens. The universe, it seems, is large enough to accommodate contradictory truths. Black holes are the universe's most extreme laboratories for studying time. They're formed when massive stars collapse under their own gravity, creating regions of space-time where gravity is so strong that it warps the very fabric of reality. Near a black hole, the distinction between space and time begins to blur. The intense gravitational field doesn't just bend space, it bends time itself, stretching and distorting the flow of moments in ways that challenge our deepest intuitions about the nature of existence. The mathematics of black holes reveal something beautiful and strange. At the center of every black hole lies a singularity, a point where the normal laws of physics break down. Here gravity becomes infinite, space and time become infinitely curved, and our usual concepts of past, present, and future lose all meaning. The singularity is not just a place where matter is crushed to infinite density. It's a place where time itself ceases to exist in any recognizable form. This suggests that black holes might be more than just gravitational prisons. They might be portals to realms of existence where time works differently, or perhaps doesn't work at all. The event horizon becomes not just a boundary in space, but a boundary in time, a threshold beyond which the normal flow of temporal experience gives way to something entirely alien. But even before you reach the event horizon, the effects of gravitational time dilation become apparent. If you could somehow hover just outside a black hole, your time would run significantly slower than time for observers far away. A day in your reference frame might correspond to years or even centuries in the outside universe. You would become a temporal island, cut off from the normal flow of time, experiencing moments while eons pass in the wider cosmos. This extreme time dilation creates poetic possibilities. Imagine a civilization that harnesses the gravitational field of a black hole to slow down time. They could send their greatest thinkers to orbit, just outside the event horizon, where they would have subjective years to contemplate problems that need to be solved quickly in the outside universe. A few hours of orbital time could provide centuries of thinking time, allowing for breakthroughs that would be impossible under normal temporal constraints. Or consider the opposite scenario. A civilization facing an existential threat could use a black hole as a refuge in time. By moving their population to a high-gravity environment, they could wait out cosmic catastrophes, letting millions of years pass in the outside universe while experiencing only days or weeks themselves. They could emerge from their temporal shelter to find that whatever threatened them had long since passed. But black holes also raise profound questions about the nature of information and memory. According to quantum mechanics, information cannot be destroyed. But what happens to information that falls into a black hole? Does it disappear forever when it crosses the event horizon, or does it somehow survive, encoded in the quantum structure of the black hole itself? This puzzle, known as the black hole information paradox, touches on fundamental questions about the nature of reality. If information can be destroyed, then the universe is not deterministic. The future cannot be predicted from the past, because some of the past has been erased. But if information cannot be destroyed, then black holes must somehow preserve every bit of information that falls into them, creating a kind of cosmic memory bank that transcends our normal understanding of space and time. Some physicists speculate that the information that falls into a black hole is encoded on its surface, like a hologram. From this perspective, the three-dimensional reality we experience might actually be a projection of information stored on a two-dimensional surface. This holographic principle suggests that space and time themselves might be emergent properties of more fundamental information processing systems. The study of black holes also reveals something profound about the relationship between gravity and time. We usually think of gravity as a force that pulls objects together, but Einstein showed us that gravity is actually the curvature of space-time itself. Mass and energy bend the fabric of the universe, creating the phenomenon we experience as gravitational attraction. And since space-time is unified, bending space necessarily means bending time as well. This unified nature of space-time suggests that time and space are not separate phenomena, but aspects of a single, more fundamental reality. The extreme environments near black holes reveal this unity most clearly. Here, the distinction between temporal and spatial dimensions becomes blurred, and the normal categories of thought, past, present, future, here, there, motion, rest, lose their clear meanings. Perhaps this is why black holes have such a powerful hold on our imagination. They represent the ultimate mystery, the place where our normal understanding of reality breaks down completely. They are cosmic question marks, challenging us to think beyond our usual categories and concepts. In their darkness lies not just the absence of light, but the presence of something far more profound, the mystery of existence itself. The dance of light and melatonin. How screens and sunlight play tricks on your time. Picture this. You're lying in bed, scrolling through your phone, and suddenly it's 2 a.m. Where did the evening go? Your brain is having a quiet argument with a tiny gland tucked behind your eyes. The pineal gland, no bigger than a grain of rice, but holding the keys to your entire relationship with time. This little gland is like a dedicated timekeeper, watching the world through your eyes, waiting for darkness to whisper its nightly lullaby. For millions of years it's been perfectly synchronized with the sun's rhythm, producing melatonin when shadows stretch long, and stopping when morning light spills across the horizon. It's been humanity's most reliable clock, more dependable than any Swiss watch. But then, we invented the light bulb. And later, the glowing rectangle that lives in our pocket. Your pineal gland doesn't know the difference between the sun and your smartphone screen. To this ancient part of your brain, that blue-white glow at midnight looks suspiciously like dawn breaking. It's like having a confused rooster crowing at the wrong hour, except the rooster is inside your head, and it controls whether you feel awake or sleepy. The science calls this circadian rhythm disruption. But imagine it more like this. Your internal clock is a gentle orchestra, with melatonin as the conductor. When natural light fades, the conductor raises the baton, and your body begins its evening symphony. Temperature drops slightly, heart rate slows, and drowsiness creeps in like a warm blanket. But when you bathe yourself in artificial light, especially the blue wavelength that screens love to emit, you're essentially shining a flashlight directly at the conductor's face. The poor conductor squints, gets confused, and the entire orchestra falls out of sync. This confusion doesn't just affect when you fall asleep, it warps your perception of time itself. Have you ever noticed how time seems to dissolve when you're scrolling late at night? Hours can slip by like minutes. This isn't just distraction, it's your brain's temporal awareness getting scrambled. Without the natural rhythm of melatonin rising and falling, your internal sense of time becomes unmoored, like a ship without an anchor. The fascinating part is how quickly this ancient system can be hijacked. Just 30 minutes of bright screen time can suppress melatonin production for up to 3 hours. Your pineal gland, evolved over millions of years to trust the sun, now believes it's perpetually summer solstice, long days stretching endlessly, with no real night ever coming. But here's where it gets really interesting. This isn't just about sleep. Your circadian rhythm is like a master clock that sets the tempo for hundreds of other biological processes. When it gets disrupted, it's like changing the speed of a record player. Everything starts playing at the wrong tempo. Your hunger hormones get confused, your immune system loses its rhythm, and even your ability to process emotions shifts. The ancient Egyptians tracked time by watching shadows move across sundials. Their days naturally bookended by sunrise and sunset. They had no choice but to live in harmony with light and darkness. Now we can create artificial summer whenever we want, but we're discovering that fooling our ancient timekeeper comes with a price. Not just in sleep, but in our very perception of time's passage. And that brings us to something wonderfully strange. When you finally do put away the glowing screens and let natural darkness return, something magical happens. Your pineal gland sighs with relief. Melatonin begins its gentle rise, and suddenly time feels different. Minutes stretch and breathe. The urgency of the day dissolves. You remember what it feels like to exist in sync with the planet's ancient rhythm. To be part of the cosmic dance between light and darkness that has been choreographing life for billions of years. The brain's stopwatch, and the stretch of boredom. Why 5 minutes at the DMV feels like 50? You're sitting in a waiting room, watching the minute hand crawl around the clock, face like it's moving through molasses. 5 minutes feels like an eternity. Meanwhile, when you're absorbed in something delightful, a good book, a conversation with a friend, a perfect sunset, hours vanish like smoke. Your brain, it turns out, is a terrible timekeeper, but a wonderful storyteller about time. Think of your brain as having not one, but several different stopwatches running simultaneously. There's the automatic one that keeps your heart beating and your lungs breathing. This one is remarkably precise, a metronome that rarely skips a beat. But then there's the conscious timekeeper, the one that decides whether you've been waiting forever or whether the evening flew by. This one is easily distracted, highly emotional, and has a tendency to exaggerate. When you're bored, your brain becomes hyper-aware of time's passage. It's like having a background app constantly checking the clock. How long has it been now? Still only 2 minutes? Really? This constant monitoring creates a feedback loop. The more you focus on time, the slower it seems to move. Your brain, desperate for stimulation, turns its attention to the one thing that's most frustrating, the relentless tick of each passing second. But here's the curious thing. Your brain doesn't actually experience time directly. It constructs the feeling of time from a constantly changing stream of sensory information, emotions, and thoughts. When you're in a boring situation, this stream becomes a slow trickle. With little new information to process, your brain has to stretch the few available moments to fill your consciousness, like spreading a thin layer of jam across a large slice of bread. Neuroscientists have discovered that we have clusters of neurons that act like internal clocks, firing in regular patterns that help us estimate durations. But these neural timekeepers are surprisingly subjective. They speed up when you're excited, slow down when you're tired, and practically stop when you're terrified. It's as if your brain's stopwatch is operated by a temperamental assistant who gets distracted by emotions. The dopamine system plays a fascinating role in this temporal theater. When you're anticipating something pleasant, dopamine floods your system, and your internal clock speeds up. Time races forward because your brain is eager to reach the reward. But in boring situations, dopamine levels drop, and your internal clock slows to a crawl. It's like your brain is saying, nothing interesting is happening, so let's make sure we notice every excruciating detail of this nothingness. There's also something called the oddball effect. Novel or unexpected events seem to last longer in memory. This is why your first day at a new job feels endless, but your 100th day there zips by without notice. Your brain allocates more processing power to new experiences, creating richer, more detailed memories that feel longer when you recall them. Children experience this constantly. Everything is new to them, so their days are packed with oddball moments. A single afternoon can feel like a week, because their brains are working overtime to process all the fresh sensory input. As we age and fall into routines, fewer things surprise us, so time seems to accelerate. The summers of childhood felt endless, not because they were objectively longer, but because they were filled with firsts. First bike rides, first camping trips, first taste of ice cream melting on a hot day. When you're waiting at the DMV, you're essentially asking your brain to exist in a state of enforced monotony. There's nothing novel to process, nothing exciting to anticipate, nothing meaningful to engage with. Your brain, designed to find patterns and seek stimulation, rebels against this sensory desert. It becomes hyper-vigilant about time's passage, counting every second like a prisoner marking days on a cell wall. But here's a gentle secret. You can change your relationship with boring time. When you shift your attention from the clock to your breath, from the waiting to the present moment, something interesting happens. Your brain stops fighting the slowness and starts finding small details to explore. The way light moves across the floor, the rhythm of conversation in the background, the subtle changes in your own breathing. Time stops feeling like an enemy and becomes simply another part of the present moment. Not fast, not slow, just there, like a river that you've stopped trying to rush, allowing it to flow at its own natural pace. Quantum time, where time forgets to show up, how equations keep moving, even when time disappears. Imagine opening a physics textbook and finding an equation that describes the entire universe, every particle, every force, every interaction. But when you look for time, it's nowhere to be found. It's like finding a recipe for chocolate cake that lists flour, sugar, and eggs, but never mentions when to bake it. This is the strange world of quantum mechanics, where the most fundamental equations seem to have misplaced time entirely. In the quantum realm, particles exist in a dreamlike state of possibility. An electron doesn't have a definite position until you look for it. It's everywhere and nowhere, like a whisper that hasn't decided what to say yet. But here's the peculiar thing. When physicists write down the equations that govern these ghostly particles, time often disappears from the mathematics, like a magician's assistant slipping behind a curtain. The Schrödinger equation, which describes how quantum systems evolve, treats time differently than space. While space can be uncertain, stretched, or curved, time in quantum mechanics flows steadily forward, like a river that refuses to be dammed. Yet when you look at the deeper equations, the ones that describe the fundamental nature of reality, time becomes strangely elusive, more like a useful fiction than a fundamental truth. Think of it this way. Imagine you're watching a movie, but someone has removed all the clocks from every scene. The characters move, talk, and interact, but there's no way to tell what time it is or how much time has passed. The story still unfolds, cause still leads to effect, but time itself has become invisible, irrelevant to the essential drama. This is what happens in certain interpretations of quantum mechanics. The universe becomes timeless, not frozen but existing in a state where all moments are equally real, equally present. It's like a vast, multi-dimensional photograph that contains every possible configuration of every particle that has ever existed or ever could exist. From this perspective, time isn't something that flows, it's something we experience as we move through this infinite landscape of possibility. The physicist Carlo Rovelli suggests that time emerges from our limited perspective, like how the concept of temperature emerges from the chaotic motion of countless molecules. We can't track every molecule individually, so we experience their collective behavior as heat or cold. Similarly, we can't perceive the timeless quantum reality directly, so we experience it as the flow of time. But here's where it gets beautifully strange. Even in a timeless universe, things still happen. Particles still interact, patterns still emerge, stories still unfold. It's like music played on an instrument that has no clock. The notes still follow each other in meaningful sequences, creating melodies and harmonies, even though there's no metronome keeping time. Quantum entanglement adds another layer of temporal mystery. When two particles become entangled, they remain connected across any distance, their properties correlated in ways that seem to transcend space and time. Change one particle, and its partner responds instantaneously, regardless of whether they're separated by inches or galaxies. Einstein called this spooky action at a distance, but it might be more accurate to call it spooky action outside of time. Some physicists interpret this as evidence that the quantum world doesn't experience time the way we do. Instead of events happening in sequence, everything that could happen already exists simultaneously in a vast web of possibilities. Our experience of time is like reading a book page by page, while the quantum universe is like having access to the entire book at once, every page equally real and present. This doesn't mean that time is an illusion, exactly. It's more like time is a emergent property, something that arises from deeper, more fundamental timeless processes, like how a whirlpool emerges from the flowing water, but isn't separate from it. Time emerges from the timeless quantum dance of possibility and probability. The practical implications are mind-bending. If time isn't fundamental, then the question what happened before the Big Bang becomes meaningless, like asking what's north of the North Pole. Before and after are concepts that only make sense within time, not outside it. And yet here you are, reading these words in sequence, experiencing the gentle flow of moments from past to future. Your consciousness seems to move through time like a boat moving downstream, even though the deeper reality might be more like a lake that contains all possible streams simultaneously. Perhaps the most beautiful aspect of quantum time is how it suggests that every moment, this moment as you read these words, is equally real and precious. In a timeless universe, there's no hierarchy of moments, no more important times than others. Every breath, every heartbeat, every thought exists with the same fundamental significance in the vast, eternal now of quantum reality. The universe's most curious equation, timelessness. Why the deepest physics whispers only of now. There's an equation that haunts physicists, whispering secrets about the deepest nature of reality. It's called the Wheeler-DeWitt equation, and its physics attempt to describe the entire universe in a single mathematical statement. But when you look at this equation, something profound is missing, something so fundamental to our everyday experience that its absence feels like a cosmic joke. There's no time. Imagine trying to describe your entire life story, But you're not allowed to use words like then, after, before, or when. You can talk about relationships, about how things connect and influence each other, but you can't mention the sequence in which they happened. This is what the Wheeler-DeWitt equation does to the universe. It describes everything while somehow leaving out time entirely. This equation emerges when physicists try to marry Einstein's general relativity with quantum mechanics. It's like trying to blend water with oil, two theories that work beautifully in their separate domains but seem to resist combining. General relativity treats time as flexible, something that can stretch and bend like taffy. Quantum mechanics treats time as a steady backdrop against which particles dance their probabilistic ballet. When you try to unite them, time doesn't just become complicated, it vanishes altogether. The physicist John Wheeler, who helped develop this timeless equation, had a poetic way of thinking about it. He imagined the universe as a vast ocean of possibility, where every conceivable arrangement of matter and energy exists simultaneously. Our experience of time, he suggested, is like being a fish swimming through this ocean, experiencing only one path through the infinite landscape of what could be. But here's the beautiful paradox. Even in a timeless universe, change still happens. It's like a river that flows without needing clocks to measure its motion. The equation describes how different configurations of the universe relate to each other, how one arrangement of particles and forces connects to another, but it doesn't need time to make these connections meaningful. Think of it like a vast, multidimensional sculpture, where every possible moment that has ever existed or could exist is carved into the same piece of stone. From our limited perspective, we experience this sculpture by moving through it, one moment at a time, like running our fingers along its surface. But the sculpture itself, the complete reality, contains all moments simultaneously. This timeless view of reality has profound implications for how we understand existence. If all moments are equally real, then nothing is ever truly lost. Every laugh, every tear, every moment of wonder exists eternally in the fabric of reality. The childhood afternoon when you first noticed how sunlight danced through leaves, the quiet evening when you realized you were in love, the moment you're experiencing right now as you read these words, all of these are permanent fixtures in the timeless sculpture of existence. Some physicists find this comforting, others find it disturbing. If everything that ever happens is equally real and eternal, what does that mean for free will? For the significance of our choices? For the weight of our actions? It's like discovering that life isn't a story unfolding in time, but a vast painting where every brushstroke exists simultaneously. But perhaps the most intriguing aspect of timeless physics is how it points back to the present moment. If time isn't fundamental, then the only thing that's truly real is what's happening right now. Not now as a point on a timeline, but now as the totality of existence, the complete, eternal present that contains all of history and all of possibility. The ancient mystics seemed to intuitively understand this. They spoke of the eternal now, of a present moment that contains everything that has ever been or ever will be. Modern physics, in its most abstract mathematical formulations, seems to be arriving at similar conclusions through equations rather than meditation. This doesn't mean that your experience of time is wrong or illusory. It's more like discovering that the melody you're hearing is part of a vast symphony that exists complete and whole, even though you can only hear one note at a time. Your journey through time is real and meaningful, but it's taking place within a larger reality that transcends temporal sequence. The Wheeler-DeWitt equation suggests that the universe is less like a movie, a sequence of frames playing one after another, and more like a vast library where every possible book exists simultaneously. We experience reality by reading one book at a time, one page at a time, but the library itself contains all stories at once. In this timeless view, every moment becomes sacred. Not because it's fleeting, but because it's eternal. Every breath you take, every thought you think, every act of kindness you perform, becomes a permanent part of the universal sculpture of existence. You're not just passing through time, you're creating eternal art in the gallery of reality, the many worlds and their branching clocks. Could each choice split time into 1,000 versions? Every morning you wake up and make a choice, coffee or tea. Take the highway or the back roads. Call an old friend or finish that project. These seem like small decisions, barely worth thinking about. But what if each choice doesn't just determine your future? What if it creates an entirely new universe, complete with its own version of time? This is the breathtaking suggestion of the many worlds interpretation of quantum mechanics. Every time a quantum event occurs, which is constantly trillions of times per second, the universe splits into parallel branches, each representing a different possible outcome. It's like reality is a vast tree, constantly growing new branches, each one a complete world with its own timeline. Imagine you're standing at a crossroads, but instead of choosing one path, you somehow take all paths simultaneously. In one universe, you turn left and meet the love of your life. In another, you turn right and discover a new passion. In a third, you stand still and have a profound realization. Each universe is equally real, equally complete, each with its own version of you, experiencing its own flow of time. The physicist Hugh Everett III first proposed this idea in the 1950s, and it's both elegant and mind-bending. It solves many paradoxes in quantum mechanics by suggesting that all possible outcomes actually occur just in different branches of reality. When you flip a coin, it doesn't randomly choose heads or tails. Instead, the universe splits. In one branch, it's heads. In another, it's tails. And both versions of you are equally convinced they experienced a random outcome. But here's where it gets really fascinating. Each branch of reality has its own relationship with time. In the universe where you called your old friend, time might feel warm and nostalgic, as you reconnect with shared memories. In the universe where you focused on work, time might feel focused and productive. In the universe where you sat quietly with your coffee, time might feel spacious and reflective. This means that right now, as you read these words, there are countless other versions of you living through countless other moments. One version of you never learned to read, and is experiencing this moment completely differently. Another version of you is reading these words in a language that doesn't exist in our branch of reality. Still another version is having this exact thought, but in a universe where time flows backward. The branching happens at every level, from the quantum to the cosmic. Every photon that hits your retina creates a universe where it hit and countless others where it didn't. Every thought you think creates universes where you thought it, and others where you did. Every heartbeat creates universes where it happened and others where it didn't, where you died a moment earlier, where you lived a moment longer. This multiplication of realities raises profound questions about identity and consciousness. If there are infinite versions of you, which one is the real you? Are you the sum of all your parallel selves, or are you just one small thread in the vast tapestry of your existence? When you go to sleep tonight, which version of you will wake up tomorrow? Some physicists find this interpretation liberating. It suggests that every path not taken in your life is actually taken by some version of you. Every opportunity you missed, every chance you didn't take, every word you didn't say, all of these play out in parallel universes. In the grand scope of reality, nothing is ever truly lost, no possibility ever truly unexplored, but it also means that suffering exists in countless forms across infinite branches. For every universe where you avoid tragedy, there's another where you don't. For every universe where you find happiness, there's another where you struggle. The many worlds interpretation doesn't just multiply joy, it multiplies everything, including pain and sorrow. Yet, there's something oddly comforting about this view of reality. It suggests that the universe is incredibly generous, allowing every possibility to exist rather than forcing reality to choose. It's like a cosmic yes and approach to existence, where every potential story gets told, every possible life gets lived. The branching also means that time itself multiplies. In some branches, time moves faster, in others, it moves slower, in some, it moves in cycles, in others, it moves in spirals. Each branch of reality creates its own relationship with temporality, its own rhythm of existence. This multiplication of time creates a kind of temporal symphony, where countless rhythms play simultaneously. Your heartbeat in this universe harmonizes with the heartbeat of your parallel selves, creating a vast, multidimensional rhythm that spans all of reality. Every moment you experience is part of this cosmic orchestra, one note in an infinite composition. The many worlds interpretation suggests that choice and time are intimately connected. Every decision doesn't just determine your future, it creates new futures, new timelines, new ways of experiencing the flow of moments. You're not just living through time, You're constantly creating new forms of time with every choice you make. In this view, free will becomes not just the ability to choose your path, but the ability to create new realities, new timelines, new ways for the universe to experience itself. Every choice you make is an act of cosmic creativity, adding new branches to the infinite tree of existence. Cosmic expansion and the future's direction. Why galaxies drifting apart might push time forward. Picture the universe as a vast cosmic balloon being inflated by an invisible force. Every second, space itself stretches, carrying galaxies away from each other like dots on the balloon's surface. This isn't just a metaphor, it's happening right now, this very moment, as you read these words. And this expansion might be the secret to why time has a direction at all. You've probably noticed that time seems to have a stubborn preference for moving forward. You remember the past, but not the future. Eggs break, but don't spontaneously reassemble. Hot coffee cools down, but never heats up on its own. This arrow of time feels so natural that we rarely question it, but from the perspective of fundamental physics, it's deeply mysterious. Most of the basic laws of physics work equally well forward or backward in time. If you filmed a planet orbiting the sun and played the movie backward, it would look just as physically reasonable. The equations don't care which direction time flows, yet our universe clearly has a preference. Everything seems to move from past to future, from order to disorder, from hot to cold. The secret might lie in the universe's expansion. When space itself grows, it creates a kind of cosmic gradient, a universal slope down which time can flow. Think of it like a river, created by a mountain. The water flows downhill, because the landscape has a tilt. The expansion of space creates a similar tilt in the fabric of reality, giving time a preferred direction. This connection between expansion and time's arrow becomes clearer when you consider entropy, the universe's tendency toward disorder. In a static universe, entropy could theoretically increase or decrease equally. But in an expanding universe, there's always more room for disorder to grow. It's like having a messy room that keeps getting bigger. There's always more space for things to become more scattered. The expansion also means that the universe is constantly creating new possibilities, new spaces for events to occur. Every moment the volume of space increases, and with it, the number of ways that matter and energy can arrange themselves. This ever-growing possibility space gives time a natural direction to flow, toward greater complexity, greater potential, greater room for things to happen. But here's where it gets really interesting. The expansion isn't just stretching space, it's also stretching time itself. As the universe grows, the rhythm of existence changes. The cosmic heartbeat slows down, not because time is running out, but because there's more space for time to fill. It's like a musical note being played in an ever larger concert hall. The same note but with more room to resonate. This has profound implications for the future of time. If the universe continues to expand and accelerate, as current observations suggest, then time itself might evolve. The far future might experience temporality differently than we do now. Moments might stretch longer, events might unfold more slowly, and the universe might develop an entirely different relationship with the flow of time. Some physicists speculate that in the very far future, when the universe has expanded to unimaginable scales, time might become so stretched that it effectively stops. Not because time ends, but because it becomes so diluted across such vast distances that nothing can happen fast enough to notice. It would be like trying to have a conversation with someone standing on the opposite side of an ever-expanding galaxy. Eventually, the distance becomes so great that communication becomes impossible. But there's also a more optimistic possibility. The expansion might not just stretch time, it might enrich it. As space grows, new forms of organization, new types of structures, new ways of being might emerge. The universe might be creating not just more space, but more kinds of time, more ways for consciousness to experience the flow of moments. The expansion also suggests that every moment is unique in a very literal sense, because space is constantly growing. The universe today is larger than it was yesterday, and tomorrow it will be larger still. Each moment exists in a universe of a different size, with different distances between galaxies, different possibilities for what can happen. This means that your experience of time right now is happening in a universe that has never existed before and will never exist again. The specific size and configuration of space at this moment as you read these words is unique in all of cosmic history. In a sense, the universe is constantly creating new forms of time, new contexts for moments to unfold. The cosmic expansion also connects your personal experience of time to the grandest scales of reality. Your heartbeat, your breathing, your thoughts, all of these are happening within an expanding universe, riding the cosmic wave of growth and change. Every moment you experience is part of the universe's ongoing journey toward greater complexity, greater possibility, greater room for wonder. This gives a beautiful significance to the present moment. Right now, as the universe expands around you, you're experiencing a form of time that is both ancient and utterly new. You're part of a cosmic story that has been unfolding for billions of years, yet the specific moment you're living has never existed before and will never exist again. The expansion of the universe doesn't just create space, it creates time, moment by moment, breath by breath, heartbeat by heartbeat. And you, right now, are part of that creation, experiencing the universe's ongoing gift of new moments, new possibilities, new ways for reality to unfold. If nothing changes, is there still time? Or is time just our way of measuring change? Imagine a universe where nothing ever changes. Not a single particle moves. Not a single wave ripples. Not a single thought forms. Every atom sits perfectly still. Every star remains frozen in place. Every possible event stays eternally suspended in the same configuration. In such a universe, would time still exist? Or would time simply have nothing to measure? This thought experiment strikes at the heart of one of philosophy's most enduring questions. Is time fundamental to reality? Or is it just our way of describing change? It's like asking whether the ruler creates the length, or simply measures it. The answer might reshape how we understand both time and existence itself. Aristotle thought time was the measure of change. Without change, he argued, there could be no time. It's an intuitive idea. After all, how do we know time is passing? We watch the sun move across the sky. We feel our hearts beat. We notice our thoughts flowing from one to another. All of our evidence for time's passage comes from observing change. But here's where it's interesting. Even in our hypothetical frozen universe, the potential for change might still exist. The laws of physics would still be there, like rules for a game that no one is playing. The particles might be still, but they would still have the capacity to move if something disturbed them. Does this latent potential for change create a kind of latent time? Modern physics complicates this picture even further. In quantum mechanics, even perfectly still particles are never truly at rest. They exist in a state of constant quantum fluctuation, vibrating with zero-point energy, even at absolute zero temperature. It's as if the universe has a built-in restlessness, a fundamental inability to be completely still. This suggests that change might be woven into the very fabric of reality. Think of it like this. Imagine a perfectly calm lake. On the surface, nothing seems to be happening, but beneath the surface, countless molecular movements continue. The water molecules are still dancing, still interacting, still creating tiny currents and flows. The stillness we perceive is just our limited perspective on a deeper, more fundamental activity. This connects to something profound about consciousness and time. We experience time through change, through the flow of thoughts, the progression of emotions, the sequence of sensations. But what if consciousness itself is a kind of change? What if awareness is not a thing that observes change, but is change itself? Consider your own experience right now. You're reading these words, and each word replaces the previous one in your attention. Your eyes move across the page, your thoughts evolve, your understanding shifts. Even when you try to focus on a single point, your awareness naturally fluctuates, like a flame that can never be perfectly still. Perhaps consciousness and time are two aspects of the same fundamental process. The universe's way of experiencing change. This raises a beautiful possibility. Maybe time doesn't exist independently of change. But maybe change doesn't exist independently of time either. They might be like two sides of the same coin, each giving meaning to the other. Time provides the dimension in which change can occur, and change provides the content that gives time its significance. The relationship becomes even more mysterious when you consider memory. How do we know that change has occurred? We remember previous states and compare them to current ones, but memory itself is a kind of change. The formation of new neural connections, the activation of different brain patterns. Our evidence for change depends on our brains changing to record and recall other changes. This creates a beautiful recursive loop. We use change to detect change. We use time to measure time. We use memory to remember memory. It's like a cosmic conversation where the universe talks to itself about itself using the very processes it's trying to understand. But perhaps the most profound aspect of this question is how it relates to the present moment. If time is just our way of measuring change, then the present moment, this moment right now, is the only thing that actually exists. The past is just memory, change that has already occurred, and the future is just potential change that might occur. Only the present moment contains actual change happening in real time. This gives incredible significance to your current experience. Right now, as you read these words, you're not just observing the universe, you're participating in the fundamental process by which reality creates itself. Every thought you think, every breath you take, every moment of awareness you experience is part of the universe's ongoing self-creation through change. The question of whether time can exist without change ultimately points back to the mystery of existence itself. Why is there something rather than nothing? Why does the universe bother to change at all? Maybe the answer is that change and time are not separate phenomena that need to be explained, but are simply different names for the same fundamental mystery, the universe's inexplicable tendency to be rather than not to be. In this view, asking whether time exists without change is like asking whether dancing exists without movement. The question dissolves because time and change are not separate things that might exist independently, but are two aspects of the same cosmic dance, the universe's ongoing celebration of its own existence. Does time need us to exist? What happens to time in a universe with no observers? Picture a universe without consciousness, no humans, no animals, no thinking beings of any kind. Stars still burn, planets still orbit, atoms still vibrate with their quantum uncertainty. But there's no one there to witness any of it, no one to remember the past, anticipate the future, or experience the present moment. In such a universe, would time still flow? Or does time somehow depend on having observers to notice its passage? This question touches on one of the deepest puzzles in physics and philosophy, the relationship between consciousness and time. It's like asking whether a tree falling in a forest makes a sound if no one is there to hear it, except the stakes are much higher. We're not just asking about sound, we're asking about the very foundation of existence. On one hand, it seems obvious that time should exist independently of observers. The laws of physics describe processes that unfold over time, whether anyone is watching or not. Radioactive atoms decay according to precise timescales. Light travels at a constant speed. Gravity propagates in waves that compress and stretch space and time itself. All of these phenomena seem to operate according to their own internal logic, indifferent to whether any conscious being is paying attention. But then quantum mechanics enters the picture, and everything becomes wonderfully strange. In quantum theory, particles exist in a fuzzy state of probability until they're observed. The act of observation doesn't just reveal what was already there. It seems to actually determine what becomes real. This suggests that consciousness plays a fundamental role in shaping reality, not just observing it. Some interpretations of quantum mechanics go even further, suggesting that consciousness is necessary to collapse the wave function, to turn possibilities into actualities. In this view, without observers, the universe would remain in a state of quantum superposition, with all possibilities existing simultaneously, but none of them being definitively real. Time might exist as a mathematical dimension, but it wouldn't have the quality of nowness that characterizes our experience. But here's where it gets really interesting. What counts as an observer? Does it have to be a human being, a dog, a bacteria, a computer, a thermostat? The universe seems to be full of systems that respond to their environment, that in some sense observe and react to what's happening around them. Maybe every interaction between particles is a kind of observation, making the entire universe a vast network of observers observing each other. This connects to something profound about the nature of time and awareness. Perhaps consciousness isn't something separate from the physical universe that observes it from the outside. Maybe consciousness is what the universe feels like from the inside. The subjective experience of physical processes organizing themselves into patterns, complex enough to be aware of their own existence. In this view, time might not need conscious observers in the way we usually think of them. Instead, time might be the universe's way of experiencing itself, moment by moment, through every interaction, every collision, every quantum fluctuation. Every particle that responds to another particle is in a sense observing and being observed. Every force that acts across space is creating a kind of temporal relationship, a connection between before and after. This suggests that time and consciousness might be more deeply intertwined than we typically imagine. Time isn't just something that consciousness experiences. Consciousness might be something that time creates. As the universe evolves, becoming more complex and organized, it develops new ways of experiencing its own temporal unfolding. Simple interactions create simple forms of time awareness. Complex brains create rich, nuanced experiences of temporal flow. The question becomes even more intriguing when you consider the role of memory in creating time. How do we know that time has passed? We compare our current experience to our memories of past experiences. But memory is itself a physical process. Patterns of neural connections, traces left by past events. In a universe without conscious observers, would there still be these kinds of traces? Would the universe still remember its own history? The answer seems to be yes. The universe is full of records of its own past. Every rock formation tells a story of geological time. Every star's light carries information about when it was emitted. Every cosmic background radiation photon contains traces of the universe's infancy. The universe doesn't just experience time, it constantly creates records of that experience, inscribing its history into the fabric of reality itself. This means that even in a universe without conscious observers, time would still leave its signature everywhere. The universe would still be a vast library of temporal information, a cosmic memory bank recording every moment of its existence. The only difference would be that there would be no librarians to read the books, no conscious beings to interpret the records, but perhaps that's where the mystery deepens. If the universe is constantly creating these temporal records, constantly inscribing its history into reality, then in what sense is it not conscious? Maybe consciousness isn't something that emerges from matter, but something that matter is always doing, experiencing, recording, responding to its own existence. This perspective suggests that time doesn't need us to exist, but it might need some form of cosmic self-awareness that we're part of. We're not separate observers of time, we're how time becomes aware of itself. Our consciousness is time's way of experiencing its own flow, of marveling at its own mystery. The universe without observers wouldn't lack time. It would lack the rich, reflective quality of temporal experience that we associate with consciousness. Time would still flow, but it would be like a river without anyone to notice its beauty, a symphony without anyone to appreciate its harmony. This gives a beautiful significance to conscious beings in the cosmic story. We're not just observers of time, we're time's gift to itself, the universe's way of stepping back and appreciating its own temporal artistry. Every moment of awareness, every memory, every anticipation is the universe experiencing the wonder of its own existence. Maybe time isn't real, but rhythm is, a closing reflection on heartbeat, breath, and the pulse of the cosmos. As you read these final words, take a moment to notice your heartbeat. Place your hand on your chest and feel that steady rhythm, lub-dub, lub-dub. This is your body's most fundamental timekeeper, a drummer that has been keeping your personal rhythm since before you were born. Now take a deep breath and notice how your lungs expand and contract in their own gentle rhythm. These are the rhythms that time your existence, and they point to something profound about the nature of time itself. Maybe time, as we usually think of it, as a river flowing from past to future, as a dimension that can be measured with clocks, isn't the deepest truth about reality. Maybe what we call time is actually rhythm, the universe's way of dancing with itself, of creating patterns that repeat and evolve, creating the music of existence. Think about it. Every process in the universe has its own rhythm. Atoms vibrate in characteristic frequencies, planets orbit in regular cycles, stars pulse with their own internal rhythms, galaxies rotate in vast, slow spirals. Even on the smallest scales, quantum particles fluctuate in patterns that repeat trillions of times per second. The universe isn't just filled with rhythms, it is rhythm from the cosmic to the subatomic. Your own existence is a symphony of nested rhythms. Your heart beats about 70 times per minute. Your breath cycles about 15 times per minute. Your brain waves oscillate in patterns that vary from moment to moment. Your cells divide and renew themselves on longer cycles. Your body temperature fluctuates daily. Your hormones ebb and flow with the seasons. You are not just alive, you are rhythm made flesh, time made conscious. This rhythmic view of reality suggests that time isn't something that contains events. Rhythm is what creates the experience of time. When rhythms synchronize, time feels smooth and flowing. When they conflict, time feels choppy and uncertain. When they stop, time seems to stop too. The meditator who finds the space between breaths, the musician who rests in the silence between notes, the lover who exists in the eternal now of a perfect moment. All of these are experiences of stepping outside the usual rhythms and discovering something timeless. But here's the beautiful thing. Even timelessness has its own rhythm. The rhythm of no rhythm. The dance of stillness. The music of silence. It's like the space between musical notes. Without it, there would be no music. Just noise. The pauses are as important as the sounds. The stillness as meaningful as the movement. This connects to something ancient and profound that every culture has discovered, the rhythm of life itself. Indigenous traditions speak of the great wheel of time, the eternal return of seasons and cycles. Eastern philosophies describe the dance of creation and destruction, the eternal rhythm of cosmic breathing. Even modern physics has discovered that the universe pulses with its own rhythm, expanding and contracting in ways that create the large-scale structure of reality. Your personal rhythms are part of this cosmic symphony. Every heartbeat participates in the universal rhythm. Every breath connects you to the atmosphere that connects all living things. Every step you take participates in the planet's rotation. Every thought you think participates in the electromagnetic field that surrounds the Earth. You are not separate from the cosmic rhythm. You are one of its instruments, one of its voices in the vast choir of existence. This rhythmic understanding of time offers a different way of living. Instead of trying to manage time, you can learn to dance with rhythm. Instead of fighting against the flow of moments, you can learn to find your place in the cosmic dance. Instead of seeing time as something that's running out, you can experience rhythm as something that's always beginning, always renewing itself, always offering new possibilities for harmony and beauty. The anxiety that many people feel about time, the sense that it's moving too fast, that there's never enough of it, that it's slipping away, might actually be a kind of rhythmic discord. When your personal rhythms are out of sync with the larger rhythms of life, time feels stressful and scarce. But when you find your natural rhythm, when you learn to breathe with the universe's breathing, time becomes abundant and graceful. This doesn't mean that schedules and deadlines don't matter. It means that beneath all the artificial rhythms we create, the tick of clocks, the buzz of alarms, the rush of traffic, there are deeper, more natural rhythms waiting to be discovered. The rhythm of your own breathing, the rhythm of your own heartbeat, the rhythm of your own unique way of being in the world. As you finish reading these words, take one more moment to notice your heartbeat. Feel how it connects you to the pulse of life itself. Notice how your breath connects you to the atmosphere that connects all living things. Feel how your awareness connects you to the cosmic awareness that experiences itself through countless forms. You are not just in time. You are time. Rhythm made conscious. The universe's way of experiencing its own eternal dance. Every moment you live adds a new note to the cosmic symphony. Every breath you take participates in the universe's ongoing creation of itself. Every heartbeat connects you to the fundamental rhythm that underlies all existence. Time may not be real in the way we usually think of it, but rhythm is real. Music is real. Dance is real. And you, right now, are part of the most beautiful music ever composed. The ongoing song of existence itself, playing its eternal rhythm through your heartbeat, your breath, your very being. In the end, maybe that's all we need to know about time. Not that it's a river flowing from past to future, not that it's a dimension that can be measured and managed, but that it's the rhythm of existence itself, the cosmic dance that we're all part of, the eternal now that expresses itself through every heartbeat, every breath, every moment of awareness. You are that rhythm. You are that dance. You are that eternal now, experiencing itself through the beautiful, temporary, infinitely precious form of your own existence. And that, perhaps, is the deepest truth about time. It's not something you have, but something you are.